Ladies and gentlemen, please join me in welcoming back to the Ash Carter Exchange the Honorable Frank Kendall, Secretary of the United States Air Force, to discuss the future of air and space power.
Morning. How are y'all doing? I don't think I'm the warm-up act this morning. I think I'm actually somebody else already did that. John Hogg, I think, was up. I've got 20 minutes. It's not a great deal of time to cover a pretty broad topic. I was asked to talk about the future of the air and space forces. I'm going to get to that a little bit indirectly, I think, in the way I'm going to approach this. I'm going to talk to you about I'm going to connect two dots, and then you can connect those to where that line extends, if you will. One of them I think some of you may be aware of. The other one probably not. The first one is that while I was out of office for the 4 years between the Obama and Biden administrations, I wrote a book for DARPA. It was a book titled The Future of Warfare. It was classified, and I wrote it as a classified book because I didn't want China to read it. We're a few years later now, and things in that book are coming true. And it's all about, in one word, autonomy. And now we've already heard during this meeting a number of people talk about programs like Replicator. John Alvin talked about the CCA, Uncrewed Collaborative Combat Aircraft that we're building, and moving to the next generation even of that. There's a lot of other things happening in other dimensions. The book that I wrote for DARPA covers all the domains. At that time I wrote it, I didn't have any idea I was going to be a service secretary of any service or military department. And I was basically trying to finish up some work that was started under Bob Work when he was deputy secretary, called the Third Offset Strategy. And I felt we hadn't really defined exactly where we were going with that, though the concept, I think, was generally clear. So I tried to write in more detail about what we do. The book is classified. If you want a copy and you have a secret zipper address and you want to send me that, and you can tell me explain how you have a need to know, I'll get your copy. But the short version of the book is automation. And I wrote chapters about each of the military domains, if you will, including airspace, land, sea surface, sea subsurface, and basically information warfare, C3 battle management, electromagnetic spectrum. And I'm now in a position where we can apply some of those ideas to the Air and Space Force. So what's happening in the Air and Space Force is really publicly what I envisioned a few years ago. We're moving forward in space and in the air to increase the use, particularly what we call artificial intelligence. I'm not crazy about that terminology. I prefer to use automation because what we're actually doing in most cases is automating functions that would have been performed by humans, and in some cases might not have been able to be performed at all because the limitations are common at both humans and processing. So that's the first data point, is this vision of a future in which our military services across the board rely more on automated processes, automated vehicles, and automated products generation to conduct combat operations. The second data point is my flight last week. Some of you may have noticed there was a fair amount, surprising to me, amount of press about the F-16 ride I took. The F-16 ride was billed as a plane that is basically implements artificial intelligence. Again, I think the more accurate description is automation. But what's being automated in this case is maneuvering and engagements in a dogfight. In the specific case of these experiments I got to see firsthand, it's about within visual range engagements. It's about engagements that happen when the two aircraft are close enough, a few miles apart, that pilots can see each other and go into maneuvers based on that and conduct operations based on that. Sensors play a big role in this too, of course, but it's shorter range, more maneuver dominated. So what I got to do, I was sitting in an F-16, but it modified to have a lot more computing power on it. It was extensively modified F-16. I got to sit in the front seat, and we went up and we tried out. There was somebody in the back seat. It wasn't a fully automated airplane. I'm not a pilot. I'm not that brave. So what we did was we went up and did a number of test points to test out multiple versions of what we called agents that would take control of the airplane and conduct the maneuvering and put us in a position, and if you wanted to, automate the engagement that might occur with either a short-range missile or with the guns on the aircraft. So we did about 10 or a dozen different situations where we set up initial conditions, And I was in the front seat, and I had a button on my stick where basically I would initiate the automation. And so once we were set up and had the right visual cues of where the threat was, the adversary aircraft, either in front of us, behind us, or in a meeting engagement, I would hit the stick, and we would start to maneuver to a position of advantage and put ourselves in a position to either get away from the other adversary or be able to open fire and engage it. That technology is not quite ready yet, but it's making very good progress. And we got to see 3 different versions of it. They all performed, I think, in a way which suggests to me personally very strongly that we're on the right path and we're going to get to where we're headed for. Now, this is within visual range. This is short range. The CCA programs that we started in the Air Force intended to be longer range. They could do close range as well, but initially they were more oriented towards beyond visual range engagements, where a variety of sensors, either organic sensors or on the fighter that's controlling the CCAs, or on the from an off-board source, a non-local source, could be providing target traction information to support engagements. Now, this is the path to the future. And people talked all day yesterday. I got a little bit of feedback about what people were saying. But what computer processing and data storage and modern mathematics and techniques are doing is enabling a degree of automation that is unprecedented. And going back again to the third offset strategy, Bob Work foresaw this. He basically talked about robotics being the heart of this. The book that I mentioned that I worked on for DARPA was about this. It was about autonomy almost entirely, and how the machines will be able to do functions that historically humans have done much faster and more accurately than we can do it. And I'll give you an example from my experience of last week. Basically, when you're in an engagement like that, what the 2 pilots are trying to do to gain advantage is fly the most optimal possible trajectory for their aircraft to gain an advantage. And generally, one of the engagements was a meeting engagement where you get into a circle and you're chasing each other around the circle. You're trying to fly your airplane more perfectly than the other guy is to gain angles on him so you can get a missile off. And he's trying to do the same to you. So the skill of the pilots is really important. We were up against a pilot who had 2,000 or 3,000 hours of experience. He was very good. It was roughly an even fight. But against a less experienced pilot, the AI, if you will, the automation would have performed better. That's where we're going. And then a couple of factors about the computers and how they work. They don't get tired. They don't get scared. They're relentless. It's easy to see a situation where they're going to be able to do this job, generally speaking, better than humans can do it. They also can handle large amounts of data. General Brown, who spoke to you yesterday, and I had a lot of conversations when he was Chief of Staff of the Air Force. Basically, what he told me, and I've confirmed this talking to other pilots, is that when you get into a complex tactical situation, you get overloaded with the amount of inputs you're getting and you're trying to sort through and decide what to do. You simplify your decision-making process down to the things that you can handle and the basic skills that you have to simplify the problem for yourself. Our computers are not going to have to do that. They're going to be able to handle that entire level of complexity much better than we can. There are just inherent limitations on human beings. And when we can build machines that can do these jobs better than people can do them, the machines are going to do the job. That's sort of the whole history of automation and industrialization over the last couple of centuries, quite frankly. So that's the very broad picture of the future. I want to cover something that's closely related to this. There's a lot of concern about the implications of automation. And after I did my flight last week, I got to sit down and talk to a couple of reporters. One of them was very fixated on concerns about essentially unleashing lethal robots on the battlefield and the risk associated with that. And what I told the reporter, what I've been telling everyone about this, is that the United States is going to follow our norms and our values and the laws of armed conflict, and we're going to ensure that we're compliant with those. There's a lot of discussion in the community about the need to regulate AI, if you will, to regulate particularly lethal autonomy. We already have rules that govern how people apply violence in warfare. They're called the laws of armed conflict. But what I think we need to do is figure out how to apply them to these types of machines. So something for you to think about as you go through the conference is this. How do we assign accountability and responsibility for the actions of the machines? At the heart of it, at the end of the day, human beings are still responsible for creating, testing, and putting those machines out and using them. So we have to figure out how to hold those people accountable to ensure that we have compliance with the norms that we all agree to. The other concern there, of course, is that our competitors may not do the same thing, may not have the same constraints that we do. The way this works in general is that the decision-making is done to apply a weapon, to engage, is done based on a set of factors that either a human or the computer has to sort through to figure out whether an engagement's permitted or not. And you can turn a dial, essentially, in terms of the sensitivity of that decision to either have fewer errors of either type, one way or the other. There's an adjustment in there. And there is an operational advantage at some point to allowing more collateral damage if it gives you a more cost-effective system. The rules don't let you do that. The rules say you cannot do that. You have to limit damage, beyond that, which is militarily necessary, basically, if you're employing weapons. And we are seeing very vivid applications of these concerns right now in at least two major conflicts going on in the world today. How much, and we've had this experience in the counterterrorism, counterinsurgency fights we're involved in, and we made some serious mistakes where we did engagements that we should not have made. But we were trying hard to follow the rules. I have sat in command centers where operations were conducted using UAVs with human control of the engagement, where we were painstakingly careful about every single engagement. We can't guarantee that our adversaries are going to be as careful as we have been. We will comply. I can tell you that with certainty. The United States is going to comply with the rules of armed conflict. And we're going to find ways to make sure that we use our systems in ways that are acceptable and don't have any more than necessary collateral damage. We won't always be perfect about that, but we're going to work really hard at it. We're going to try very hard to implement those rules. I can assure you that, at least. I can't say the same about our adversaries. And there may be an operational advantage to not doing that. That's the reality that our forces may face. So we're in a race, and what a comment I made last week was that we're in a race to field this kind of capability, and we better move fast because the other side's doing it as well. This is not a mystery that this is possible. What you have right now in the department, to kind of give you a summary of kind of where we are overall, is we have a lot of our normal programs moving forward and incorporating various forms of AI for pattern recognition and so on like that. We have for some programs that have been accelerated, and then the CCAs is an example of that, where we're going to take a few years to do a design and go through some testing and then do fielding. We're well underway with that. We got some help from the Congress last year with the Quick Start Initiative to start things earlier, which will help accelerate programs. But a certain amount of engineering is needed and a certain amount of testing is needed, and then production lead time to get things into the field. So we just announced the award of 2 finalists for Anduril and General Atomics for our first tranche of CCAs. General Alvin told you yesterday about how we're moving forward on the second increment of CCAs. We're going to learn from the first. We're going to feel we'll have uncrewed aircraft that are carrying weapons in the force by about 2030, and we'll have to put them in. My general guidance for my acquisition people is structure programs to put meaningful capability in the hand of operators as quickly as possible, and that's what we're trying to do. We're going to learn a lot from increment 1, and increment 2 is not going to be very far behind. The Deputy Secretary has started the Replicator Initiative, which is meant to go even faster. And I think Doug Beck has talked to you about what he's trying to do there with those programs. So this is all moving in basically the same direction. I think the future is becoming clearer. I think the only question that really may remain is who's going to get there? Who's going to get there first? And what are the constraints we might place on ourselves going to do to limit our operational effectiveness relative to our adversaries? And how do we manage our way through that? I've talked mostly about the air domain. The same is true essentially pretty much in the space domain. Space is already highly autonomous, and it's getting much more so. I visited space companies that essentially have control systems that are uncrewed. Obviously, the satellites are not crewed. Large constellations in orbit where there's a control center somewhere where once upon a time you would have seen, a dozen or so people at consoles monitoring what was going on are empty. And the people that are actually paying attention to the satellites are walking around doing whatever they do normally, carrying a cell phone with an app on it. And if something goes wrong with that constellation, they get an indication on their app, and they can deal with it remotely from wherever they are. That's a very high degree of automation. Problems that we once thought were incredibly difficult, the ability to manage and orbit a very large, complex constellation have been solved. And we now have constellations in orbit that have thousands of satellites, actually, and more on the way. So space presents a particular operational problem, though. The difficulty in space that makes it almost unique is that people's assets are generally already deployed on the battlefield, and they're visible to the other side. And there is, because of that, it's sort of, I characterize it, this is the way I characterize it in my book, is sort of a no man's land, where both sides have the terrain under observation and under fire, potentially, and either side can act at any time that they want. That's a dangerous situation because inherently it creates a first mover advantage. If you have deployed weapons that can be lethal very quickly, and again, we're talking about a high degree of automation here because the numbers are large and a lot of things have to happen simultaneously. But the first mover advantage and the ability to respond to that first mover effectively is really a serious problem. I think I can tell you with pretty good assurance that we're not going to be the aggressor of the United States. So we have to be prepared for the other side to make that first move. And the scenarios we tend to like to model and evaluate in space historically have been war games I've been in, have historically been examples where something happens over a period of time and then somebody makes a move against a satellite. And then the other side tries to figure out what to do about that. That's not the scenario I think we need to worry about. What we need to worry about is a scenario in which the other side makes a lot of moves against a lot of satellites simultaneously, and we have to respond. There's no way human beings are going to be able to sort through all of that in the time scale that's required and make the sort of decisions that need to be made. That's a very dangerous situation. It's a hair trigger situation where the responses on both sides could be really problematic. But you need to be prepared for that. A lot of the work that we're doing right now on modernization, what started out as under the broad label of JADC², and then for the Air Force became Air Battle Management, so Advanced Battle Management System, which for us does include both air and space. We're working them both together, and we'll be doing that for the joint force as a whole. It's going to have to be a system, again, which is highly automated, that takes into account an enormous amount of data, processes it, and gives us reliable conclusions that we can act on. Humans will still be in control. In all these situations, we are not going to walk away from human control. We are not going to walk away from human oversight, and we're not going to walk away from compliance with the norms that the United States is going to follow. But we've got a lot of work to do to mature that and put it into a position where we can use it. It's happening. It's happening fairly quickly. I'm really, since I wrote the report, the book for DARPA, I'm kind of astonished at how fast things are moving forward. Had some control of that up to a point in with the Air Force and Space Force personally, but across the board, these things are happening. They're visible. We can see them. The technology, I did not anticipate ChatGPT, for example, but I did anticipate highly autonomous and in many cases lethal systems that we're going to have to design so that they're compliant with the laws of war and so on. That's a broad picture of the future. We're moving forward as quickly as we can. A lot of you have been heard me last year when I spoke to this forum. I talked about the operational imperatives. We're continuing that work. The threat is not standing still. The threat has got all this, understands all this as well as we do, and is trying to move forward quickly. We suffer, and I know a number of speakers have talked about the implications of continuing resolutions and so on, and our political gridlock that we tend to get into. To put that in perspective, in the last 15 years, we have spent 5 years under CRs. We have given away a third of the available time when we could have been moving forward. The CCAs that were just awarded, they were awarded basically as we had scheduled. But if the budget had not passed when it did, we could not have awarded those contracts. We're dependent. We move at the pace of engineering and at the pace of money. Those are the things that drive us. Right? And we can do certain things about engineering. Some of the digital technology that's matured now, and it's still maturing, allows us to move much more quickly in the design process and transition things into production. I just saw an example of that yesterday with some of our leading edge thinkers in the Air Force down in Alabama. So we can move quicker, but there's limits to how much you can do there. The more complex the product is that we want, the longer it's going to take to get it. The more concerned we are about compliance with certain norms of behavior and so on, the more testing we're going to need to do. So there are gains that can be made there. But the thing that's sitting right in front of us, right on the plate in front of us, is the funding. I'm hoping we can expand the Quick Start initiative with the Congress. We've got 2 programs up and running there. We just announced them. One of them is more resilient GPS for both civil and military users. The other is integrated moving target indication, C3 battle management, which will apply to the Air Force and Space Force and integrate assets there. Both critical things that we want to move forward with. And we got a head start on those thanks to the Congress. We're not waiting for the 25 or 26 budgets to be passed to get those moving forward. So I really appreciate that support. We need to do more of that. I think the nation tends to be a bit polarized right now. Hopefully this is something we can unite about. One thing that I think there's agreement about between the 2 parties is that our 2 main political parties is that China's a problem. China's a strategic threat. And I've been beating this drum for almost 15 years now. So hopefully we can work together and we can move forward. If we don't, I think the consequences are going to be very severe. And I think I'm out of time. So I did that just exactly to my 20 minutes. Thank you very much for your attention. Enjoy the rest of the show.
Okay.
I don't want to leave the stage without saying a word about my friend of 40 years, my colleague, and the person who I get to work for multiple times, Ash Carter. He would have loved this. He would have loved this dialogue. He would have loved this conversation. He would have had a zillion ideas and been really engaging this. If there was one thing I loved about Ash, it was his creativity, his innovation, his very open, eager, and broad mind, and the depth at which he could do things. So just want to shout out to the Carter family and all those from his team. Julie's out here. There are others who were part of that team before. Thanks for doing this. It's a great tribute to Ash. We'll get to have this conversation. Thank you.
Yeah.